Assalamualaikum and good day to lecturers and viewers. Today, me and my group from BMKT will present our assignment of force and factor of safety analysis from actual structures for BMKT 2323 Solid Mechanics. My name is Muhammad Daniel Hakim bin Masih Syam, and these are my groupmates that work together to complete this analysis. First and foremost, we start with structure selection. We successfully photographed 3 structures from real life that requires force and safety analysis. We decided to go for the traffic light system as it is suitable for clear free body diagram sketching and straightforward calculations. Its structure also imposes a safety concern towards road users, as factors such as wind force, structural integrity and durability could make the structure dangerous to road users.
For the structure, these are the most common material used in a traffic light, which is galvanized steel, aluminium and reinforced concrete. For the galvanized steel, this material chosen for its high strength and corrosion resistance, making it ideal for outdoor use where it is exposed to weather like rain and humidity. Next is aluminium. This material have a lightweight and has a good thermal conductivity. It's typically used for the traffic light housing to help with heat dissipation from internal electronic components. Lastly, reinforced concrete. This material especially for the base foundation. It offers high tensile strength and very durable, supporting the entire traffic light structure effectively over time.
Hello everyone, my name is Muhammad Harith Nizan, and now I will briefly present the key safety requirement for the traffic light post. First, we have wind load resistance. The traffic light post must be designed to withstand the high wind speed. During storm and monsoon season, it's critical that posts experience minimal deflection under lateral wind pressure to maintain visibility and prevent failure collapse. Second, we focus on structural integrity. The pole must be strong enough to resist buckling, and it should be able to endure fatigue from repeat loading and environment stress. And lastly, electrical safety. Electrical safety for the traffic light involve on components and proper grounding, isolation and waterproofing. For the place, the vital prevent the electrical hazards such as short circuit or electrocution, especially during rainy weather. And now I present the idealized model for the traffic light. In this model, we assume the post behave as a vertical cantilever, meaning it's fixed firmly and at the base and free at the top. This is commonly used to represent how poles behave in real-life structural analysis. There are no additional elements such as brackets, overhanging arms. All loads, including the weight of the traffic light and wind force, is considered to act directly along the pole, either vertically or radially. And now, moving on to methodology. In methodology, we talk about the free body diagram with the calculation for all the force, moments and dimension of the structure, and the analysis to get the safety factor of the traffic light.
For the FBD, the structure consists of a vertical pole that is fixed to the ground, supporting the weight of the traffic light housing and the pole itself. Horizontal wind forces act on the surface area of the traffic light housing and the pole. At the base, the ground provides a vertical direction force upwards to support the total weight of the traffic light system. Horizontal force to counteract the wind forces, and moment reaction to resist bending moment from the wind forces. So based on the dimensions and mass of the traffic light that we can gather, load and mechanical response analysis can be done.
Now, Let's look at the load and mechanical response analysis. The vertical force from the weight of the pole and the light is 387.5 newtons. The horizontal force from the wind is 43.7 newtons. This creates a moment at the base of 452.94 newton meters. We calculated the axial stress is 0.00493 megapascal and the bending stress is 46.12 megapascal. So the total stress of the axial and the bending stress is 46.125 megapascal. With the material strength of 250 megapascal, the safety factor is 5.42, which means the structure is safe and strong.
Now, let's discuss the structural behavior of the traffic light pole. First, fatigue over time is a significant concern. Continuous exposure to various loads, especially from wind and traffic vibrations, can weaken the material over time. Second, traffic light poles demonstrate high resistance to force, particularly axial and lateral loads, which are critical for maintaining stability. Next, wind forces play a critical role. The effect of wind and environmental factors can create bending moments at the base of the pole. This highlights the importance of the robust design to mitigate stresses caused by these forces. Lastly, corrosion considerations must not be overlooked. Regular maintenance is essential to prevent degradation, particularly at joints and areas exposure to moisture. Next, our suggestions for improvement regarding the traffic light pole. First, we recommend improving the foundation design. By deepening or widening the foundation, we can better distribute stress, enhancing stability against lateral forces. Second, the installation of vibration dampers is critical. These dampers or flexible joints can absorb oscillation, significantly reducing long-term material fatigue caused by traffic and environmental vibrations. Third, we must enhance corrosion protection, regularly reapplying protective coating and conducting inspections for sign of rust will help maintain the integrity of the pole, especially at joints and base areas exposed to moisture. Lastly, we suggest monitoring safety factors more closely, conducting yearly evaluations based on updated structural condition will ensure ongoing safety and reliability.
Finding for chapter 5. Based on the analysis, the traffic light pole can support a vertical load of 387.5 Newton without experiencing any critical stress. Wind loads create a bending moment of 452.94 Newton meters, but this is still within the safe design limit. The bending stress calculated is 46.12 megapascal, which is much lower than the material's yield strength of 250 megapascal. This gives a safety factor of 5.42, meaning the structure is very reliable. The material used like galvanized steel and the foundation also contribute to strong, resistance and durability. Next, to improve the structure further, we recommend upgrading the foundation by either deepening or widening the base. This will help with better stress distribution. Adding vibration damper is also advised to reduce the fatigue caused by constant traffic vibration. Protective coating should be reapplied regularly to avoid corrosion and extend the pole lifespan. Lastly, the safety factors should be monitored yearly because long-term environmental exposure can slowly weaken the materials. In conclusion, the traffic light pole is currently safe and perform well under existing conditions. The stress levels are far below material limits and the safety factor is high. However, to maintain this performance over time, it is important to perform regular maintenance, improve the foundation, and control vibrations. This action will help ensure the structure stays strong and safe for the long term. Okay, that's all from me. Thank you.